Okay, so the master cube, the perimeter, very important, right? I'm going to lay it down here. Nice and light. The outside perimeter is what's closest to us. Okay. Right, I'm going to put that back plane in there. Nice and easy. That's just a general box plane. Right, space is moving towards us, right? And then I'm going to put in a line of sight here. Okay, and I'm going to do a draft of volume with a single line perspective. Okay, first thing I'm going to do is I'm going to put in my height line. Okay, I'm going to do this freehand. Okay, that's the height of my volume, right? And then I'm going to hit my, maybe I'll use a ruler for this part. It's always a good idea. Okay, I'm going to hit my points. Okay. Okay. And then I'm going to draw this side, right? The height. Okay. And I'll use the ruler again. This is a single point perspective. Okay. Then I can draw in this side and the top. Right? And that represents a volume. Okay. And in theory, if we were to place an object in this volume, right? Here's the center axis, right about there, and we could put an apple or a sphere, okay, into that volume, right? It can be any object, okay, and the idea is that objects fall within volumes. They occupy volume, and that's your dominant direction, okay? So that's just an idea of single point perspective, okay? How to draft a volume, okay? And you should practice that several times, right? And so if I locate a volume above the line of sight, you can see we're kind of looking up at the object, right? We're seeing the underneath of that volume and the inside underneath, right? So that gives you a sense of how that line of sight works, right? And there's infinite number of these vanishing points on that line of sight where things can be pulled from, okay? But everything comes from there and goes there, okay? I would like to, and that's just make a little bit of a note about the line of sight and how the line of sight relates to volume. Okay, so let's create this master cube. Okay. Okay, here's the master cube, right? And so let's put a line of sight right there. That's way, 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 way off in the distance, right? The line of sight. Things are moving towards us like this, right? And so the illusion here is that if we were to put little tick marks every foot, let's say, right? As it gets closer, things get closer, the distance between these lines gets further and further apart as we get closer, right? And so if we spoke about the footprint of objects, right? So watch this. So the footprint of the object that's closer to us, right? The distance between the front and the back is quite large. And then when we go further back in space, the distance is shorter. And as we go further back in space, the distance is even shorter until it almost flattens out. Okay? And it works vice versa, right? 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 So further away, it's flat. The distance as we get closer, right? And further apart, and further apart as it gets closer. Okay? So the idea is that everything opens up as it goes back into space all the way to the infinity. Right? Everything's moving towards us. Right? Above our line of sight and below our line of sight. This is our line of sight. Line of sight. Right? And that's a constant. When you move your head or you move your vantage point or wherever you're looking from, that line of sight exists way off into the distance. So everything else is moving towards us, right? So let's look at how that relates to our volume and the placement of objects. So I'm going to place an object close to us, right? So I'm going to keep that distance nice and large, right? And then you see how this is a little cylinder higher that we're going to draw here, right? It's going to be located nicely in relationship to the whole volume of the page. Okay? And you can see this distance of the footprint, this distance, nice and far apart. Now if we locate another cylinder back here, we're going to flatten out the footprint, right? This distance gets shorter, right? And if we go above the line of sight, right, we're going to be looking up at that ellipse there, right? That distance, same as this distance, right? Okay, and so here we go. Front, back, and these ellipses are following the same concept here. As I'm going to get closer to the line of sight, that ellipse is going to flatten out. Okay. Up. And as I get closer to the line of sight, it's going to flatten out. There we go. It's flat. And now I'm going to be opening it up the other way as I'm looking up. That's the front. Okay? Flattened out here, and then it begins to open up as you go below and above. Okay? Okay. There you go. So we're looking up, inside, down, here. Okay? And so this lesson, you can make reference to this two-point perspective You can make reference to this material through the course Blackboard interface. There's a whole bunch of these documents there you can print out and you should become familiar with. As you can see, there's our horizon line, our vanishing points, right? And you can see how objects above, you're looking underneath them, below, you're looking above them. Same thing here, right? That's the line of sight, eye level. Everything's flat, and as you look above, things open up, and below, they open up, and you're looking down at things, right? So you have to get familiar with that material that we've covered here. Okay, this would be like a vanishing point here, right? And there's millions of vanishing points, an infinite number of vanishing points throughout this line of sight, right? They're everywhere. Okay, all this. See the way that relates? Okay. All going to the infinite vanishing point. Vanishing point. Okay? So you get the idea how the space opens up as it comes closer to us, right? And it diminishes as we go further and further away into the space, right? So you should do a drawing like this, practicing and orienting yourself with this idea, this concept, right? And understanding how things fit together. Okay? Very good.